Okay, let's dive into this. Welcome to today's Explainer, where we're going to unpack a seriously fascinating micro-ecosystem mystery. If you've ever kept a fish tank, or frankly, even just tried to keep a single houseplant alive, you know that keeping a captive environment perfectly balanced is basically like walking a tightrope. One little slip and whoosh, things go sideways. Today we're looking at a brilliant piece of observational science, drawn straight from the personal fish-keeping notes of an aquarist named Ang. We're going to examine a localized ecological disaster that unfolded inside just one single aquarium. It's really the perfect case study of how quickly natural balance can tip into absolute chaos, and we're going to track exactly how the whole thing happened.
Our source material kicks off with this wonderfully honest, totally straightforward entry. Ang writes, "Dear Interweb, there is one of these particular aquarium tanks which is currently infested with an algae bloom." I love that. That simple statement instantly sets the stage for us. We're not looking at some pristine, perfectly manicured showpiece here. No, we are looking at an active, living crime scene. It's got this deeply personal, observational tone to it. You see, Ang isn't just rushing in to scrub the glass or dump a bunch of chemicals into the water at the very first sign of trouble. Instead, they're taking a step back. They're actually documenting and trying to understand the ecological breakdown as it unfolds right there in real time.
And hey, that brings us right to the central victim of our little mystery, and the core question we really need to answer today. Why on earth is the Common Salvinia dying? Now, Common Salvinia is a floating aquatic fern, and in this specific tank, it is failing rapidly. It's turning yellow, it's browning, it is flat out losing its battle for survival. But as you know, in a closed environment like an aquarium, literally nothing happens in a vacuum. Everything's connected. So to find the true culprit behind these failing plants, we got to put on our detective hats and investigate a few key ecological suspects.
Let's lay out the parameters of our crime scene, shall we? The environment is this totally algae-infested observation tank. But there's a witness in there, or, well, maybe an innocent bystander. The tank is inhabited by a single polar parrot cichlid. Now, Ang playfully refers to this fish as the gardener of the tank, which is a great little detail. It highlights a very deliberate, calculated choice by the author. Think about it. Most people would instantly do massive water changes to eradicate that ugly green bloom, right? But Ang opted to keep it strictly as an observation tank, basically letting the cichlid act as the sole caretaker while the underlying biological drama plays itself out. It's exactly this kind of patience that gives us such incredible data to analyze. Now, what's really interesting about this slide is the clear, undeniable contrast between our victim and the control group. We've got the yellowing, browning Common Salvinia from our observation tank looking incredibly sickly and depleted. But, and this is a crucial piece of evidence from the source, Ang's Common Salvinia in their other tanks is absolutely thriving. Boom! This proves, beyond a shadow of a doubt, that we're dealing with a highly localized attack. This isn't just a bad batch of plants from the fish store, and it definitely isn't a general failure of Ang's fish-keeping skills. Whatever is killing this plant is specific and completely unique to this single glass box.
All right, let's bring in our very first suspect, the algae thief. When we look at the intense algae bloom just completely clouding up the water, we have to realize it's not just an aesthetic nuisance, it's a hardcore biological competitor. In the strictly confined space of an aquarium, resources are super limited. It's a zero-sum game. The algae isn't just peacefully coexisting with the Salvinia, it is actively fighting it for survival. We really have to treat this intense algae competition as a greedy thief, relentlessly stealing the exact vital resources that our floating fern desperately needs to stay alive. To understand exactly how this theft goes down, we need to look at what's missing from the water. The algae is out there rapidly consuming the vast bulk of the available nitrogen and essential minerals. I mean, these are the fundamental building blocks of plant life. By aggressively gobbling up these elements, the algae is leaving practically zero behind for the Salvinia to absorb. Remember that yellowing and browning we talked about earlier? Well, that is the absolute textbook visual symptom of profound nutrient starvation. The plant is, quite literally, starving to death while swimming in an ocean of competitors.
And this brilliantly illustrates that the algae's assault isn't just an invisible chemical theft, it's actually a physical attack too. The author notes a devastating mechanism at play here. First off, the algae physically coats the delicate roots of the Salvinia, just smothers them. Second, this slimy coating acts as a physical barrier, which further hinders whatever tiny bit of nutrient uptake the struggling plant could still manage. And third, and honestly perhaps most fatally, it blocks gas exchange. Roots need to breathe. They need to interact with the water to survive. So by totally coating them, the algae is effectively suffocating the Salvinia. Talk about a brutal 1-2 punch.
But hey, as any good investigator knows, you can't get tunnel vision, right?
We have to pivot to our second suspect, which takes us away from direct biological warfare and straight into the realm of environmental factors. Suspect 2 is the blinding light. We really have to stop and ask, is it at all possible that the plants are actually suffering from something entirely unrelated to the algae?
Well, a critical clue emerges right from Eng's notes. For the past 3 days, this specific observation tank has been exposed to significantly higher levels of LED light than any of the surrounding tanks. Now, obviously, light is absolutely essential for photosynthesis, we all know that, but an intense, sudden spike in lighting over a tight 3-day period, that introduces the very real possibility of severe light burn. Think about it. The poor Salvinia might be getting scorched from above by the LEDs while simultaneously being starved and suffocated from below by the algae.
So, let's move to and see how this builds into a grand unifying theory for our ecological mystery. While the algae thief and the blinding light are undoubtedly major contributing factors, Eng suspects there is a true puppet master pulling the strings behind this entire collapse. The mastermind here? It's water quality. Specifically, the source points to rapidly fluctuating pH and ammonia levels. When water chemistry gets unstable like that, it causes massive, unnecessary systemic stress to the aquatic plants. It completely weakens their natural immune defenses. Essentially, it creates an environment where algae can just absolutely thrive, while higher-order plants suffer and crash. That unstable water quality is the hidden foundation that allowed the light stress and the algae invasion to become so lethal in the first place.
So, the crucial point is figuring out what comes next. Now that the author has observed this collapse and identified the prime suspects, action has to be taken to restore the balance. Eng plans to experiment with 2 distinct pathways to fix this. On one hand, we have physical treatments. This could mean dialing back that intense LED lighting, or perhaps eventually getting in there for some manual removal of the algae. On the other hand, we have chemical treatments, intervening directly to buffer and stabilize those volatile pH and ammonia parameters. The goal here has shifted. It's no longer just passive observation, we are moving into active, targeted recovery.
Which brings us to a final, really lingering thought. We've just witnessed how a few seemingly tiny shifts, a spike in light, a greedy little algae bloom, some fluctuating water chemistry, can completely crash a micro-ecosystem. Eng is gearing up to test these treatments to try and save the Salvinia. But as we wrap up this explainer today, I want you to consider this. Will these physical or chemical interventions actually be enough to truly stabilize the water? Or has the delicate balance of this ecosystem been permanently altered, forever shifting the dynamic between the plant, the algae, and that lone cichlid gardener? It is a powerful, fascinating reminder of just how fragile the natural world can be, even when it's contained inside a small glass box.